Okay, this is the lecture video for MAC1114, section 7.5, where we're looking at sums and differences for the trig function sine, cosine, and tangent. This is the second video, and in this video we're going to be doing numbers 11 through 14. Okay, so we pick up with example 11. We're doing tangent of 105, and as you've seen in the other problems in this section, we are breaking this angle up into either 30, 60, or 45, or something that's related to 30, 60, or 45 through its reference angle. Okay, this can be broken up into tan of 45 plus 60. It doesn't matter which of those angles you mentioned first. Then you have to know how to expand a sum for tangent using the formula that was presented in this section, and that would be tan of 45 plus tan of 60 in the numerator. And then the denominator would be 1. Switch the sign from whatever it was in the numerator, switch that sign, and then do a product of the same two values that you had in the numerator. Tan of 45 times tan of 60. Before you start plugging into this fraction, just so you don't have to write that great big fraction over and over again, you may want to go calculate what the tan of 60 and the tan of 45 is off to the side. I'll do the tan of 60 first. 60-degree angle means you have a central angle of 60 degrees right there at the origin. Always across from the 60 is the long leg, and across from the 30, which would be this other angle, is the short leg. Vertical leg plays the role of the Y, while the horizontal leg of your triangle plays the role of the X. So if you wanted the tan value for this situation, set central angle at 60, that's always the angle that's mentioned here, and you're using that formula, it would be square root of 3 over 2 divided by 1/2. To simplify that, you would float that denominator up to the top, thereby multiplying by the reciprocal, which is the same thing as dividing by 1/2. So that's not there anymore, it's up at the top. The 2's cancel, leaving you with square root of 3. So that's your tan of 60 value that you're going to be plugging in here and here. And then tan of 45, you may be able to do that in your head, but I'll remind you what the situation is anyway. You have a 45-degree angle as your central angle, which means this angle is 45 also. And in that situation, both legs are square root of 2 over 2. So that when you go to find the tangent of this 45-degree triangle, you're just doing this y value over this x value. You got the same y value as you do the x value. Therefore, your tan value is 1. Okay, then you need to plug these values and simplify. These tan problems have a lot of algebra in them, as opposed to cosine and sine, which is the case in every section where you're presented with formulas for cosine, sine, and tan. So tan of 45, 1. Tan of 60 plus tan of 60. Tan of 60 turned out to be this square root of 3 value. And then on the bottom, it's 1 minus tan of 45 times tan of 60. So tan of 45, once again, is 1. Tan of 60 is square root of 3. Okay, so on the top you have 1 plus square root of 3, and on the bottom you have 1 minus square root of 3. So you're going to be expected to rationalize these, and whenever you're trying to get rid of square root of 3, but it's hooked to another integer by way of a plus or a minus sign, it's going to require not just multiplying bottom and top by square root of 3, but multiplying by the conjugate. Okay, so the conjugate of this would be 1, reverse the sign, same front terms, same back terms. And whatever you multiply the bottom by, you have to multiply the top by the very same thing. Okay, that brings into play the shortcuts that I've been stressing throughout this section. only because these problems are so long that you need to be making use of any shortcuts that have been stressed in this class and previous classes for foiling. So now we're at the point in the problem where we're going to FOIL on the top and FOIL on the bottom. However, look what we're foiling. We have a binomial here that we're squaring. This is 1 plus square root of 3 squared. You're multiplying two terms by the same exact two terms. And when you're in that case, instead of foiling and having 5 or 6 steps, you can just go square, double square. And that will be a shortcut to squaring 1 plus square root of 3. So just square, double square. That is used when you're squaring a binomial. On the bottom, you have binomials as well, but these happen to be conjugates because they have opposite signs. And the shortcut for foiling that is square minus square, and that'll cut out 3 of the steps. So making use of those shortcuts, I'm not going to continue. I'm going to use square, double square. When you use either of these shortcuts, you can be looking at the first binomial or the second one, doesn't matter. I'm always going to look at the first one, it's just easier. Okay, so square that first term, you get a 1. Double the product of these. The product of these is 1 times square root of 3. You'd have a 1 right in front of there, just this times this. But then you're doubling the one that's out front to give you 2 square roots of 3. Now square again. Square this back term, and you get a 3. Both of the square values have to be positive because you can't square and get a negative. Whereas this middle term will take on the sign, that common sign in both of the parentheses. You want to continue simplifying the top. You have like terms in the front and the back, that's 4, plus your radical term, 2 square roots of 3. On the bottom, we're going to do square minus square to get this all FOILed out. So I'll just be looking at this binomial, so square the front, that's 1, square the back, that's 3, and then put a minus sign in between them. You can further reduce this by going 4 divided by negative 2. I'll do that here. You can split this up into 2 fractions, thus allowing you to reduce this. Okay, so 4 divided by negative 2, negative 2. 2 divided by negative 2 is negative 1, square root of 3. And that's your final answer for that particular problem. Okay, moving to number 12. Problem number 12. Unfortunately, it is 4 parts, and you're going to have to build the triangles that are used to get the values for each of the 4 parts. So, building a triangle for this alpha situation, and let me, go over with you how to read these directions. This mention here of alpha being between 0 and pi over 2, they're telling you what quadrant to spin into in order to create your triangle. If you're going to be between 0 and pi, well, let's just review. This is 0. This location right here, 90 degrees, is also called pi over 2. This is red. You read this from the middle. So this is red. Alpha is between 0 and pi over 2. I'm talking about the spinning arm, which ends up being your hypotenuse. So you're like this, come down to the x-axis, and you've created your triangle. Whoops, I'm not showing you that. So here's 0. This is pi over 2. You are to spin so that your alpha angle is between 0 and pi over 2. That's this arm right here, the spinning arm, which really becomes the hypotenuse. Let's label this as the central angle being called alpha. Now go put the numbers on the triangle that you've been given. You've been given the y value and the r value because they say that this fraction represents sine, and sine is defined as y over r. So here's your y value. It is equal to 9. Your r value is the hypotenuse. So the hypotenuse is 41. And then you're missing one value, which is going to be needed when you do these formulas. So we can always use Pythagorean theorem when we are missing one of the 3 values in a right triangle. So I'm going to do that over here. Okay, the Pythagorean theorem goes hypotenuse squared is equal to legs squared. One of them is 9, this vertical leg, and then we're looking for x plus other legs squared. Okay, so when you square 41, you get 1681. When you square 9, you get 81. We're trying to solve for x squared, which means we're going to bring this 81 to the other side, thus making it negative 81. So 1681 minus 81, you have 1600 is equal to x squared. And then if you want x, you're going to take the square root here, square root here. So x turns out to be 40. And you can put that right here because we're going to be looking at these triangles throughout the problem to do all 4 parts. Okay, then we're going to create another triangle based on this set of parameters. First, spin to where they tell you to create beta. Beta is an angle created between negative pi over 2 and 0. So they're mentioning a negative angle. So first of all, you have to know how to spin negatively. Okay, there's 0. When you're spinning negatively, you're dropping this way, and this would represent negative pi over 2. Okay, so this triangle that you're going to create, called beta, it has a central angle called beta, is between 0 and negative pi over 2. So let me get this out of the way. Just reminding you how to spin. So your hypotenuse is between 0 and pi over 2. And then if you want to close up that triangle, then you just come right back up to the closest x-axis, which would be this positive x-axis. Close that up and put the values on that triangle that you've been given here. This represents cosine. Cosine is defined as x over r. So your x value is 2 square roots of 53. And then this would be your y value. Y values are negative in this quadrant. So your y value would be whatever we get from Pythagorean theorem, and we do have this r value of 53. So now let's do Pythagorean theorem and get that missing value. I'm just putting this negative here to remind us that it's negative, because otherwise it ruins any answers that incorporate that value. Okay, so hypotenuse squared, I can just do it right here. The hypotenuse is 53. I'm going to square that, and then it's equal to legs squared. Here's one of your legs. This leg squared plus the unknown value for y. We don't need to put the negative in here. We already know it's going to be negative, plus y squared. Okay, so 53 squared, that gives you 2809. And then when you square this, you have to square the 2 as well as the square root of 53. Squaring the 2 will get you 4. Squaring this square root will get you 53. So 4 times 53, that turns out to be 212. Okay, that's 4 times 53. When you square both parts of this, the coefficient gives you 4, squaring this gives you 53. That's where the 212 came from. Then if you're going to isolate y squared, that means you have to bring this over here, at which point it becomes negative 212. So then you're looking at y squared is equal to 2809 minus 212, which is equal to 2597. Okay, then you're going to go into the part where you turn this into y by taking the square root, and then you have to perform same operation here. Now that's a pretty big number underneath the square root, so I'm going to see if I can possibly break this number down and take a partial square root to help with the reducing in the problem. Okay, so let's see. When you're breaking down these square roots, you want to think of anything that is a square that you can take the square root of that's actually a factor of this, like the number 4, there's a square root for that. The number 9, the number 16. the number 25. I'm going to go with, just because this ends in sevens, and I know there's a square root with 49, which also has a factor of 7. So I'm going to try and break this down using 49. Let me see if 49 goes into there. So anything that there's a square root, a biggest number you can try, and you can just keep trying them. But you have to know things that there's square roots of. There's square roots of 4. There's a square root of 16. This is just 2 squared. This is 3 squared. I skipped over that one. This is 4 squared, 5 squared, 6 squared, 7 squared. I'm thinking of things that there's square root of, and I'm using that to break this down. I'm going to see if 49 goes into this. So 2, 5, 9, 7 divided by 49, and this is 53. So there is something that that's a factor of 2597. It's this number. You can take this out from underneath the radical, taking the square root as you do so, and leaving the 53 inside. So that simplifies as the partial square root 7 times square root of 53. Okay, that's the y value in this particular problem. Go put it on the triangle, because you're going to be looking at this triangle over and over again as you try to do parts A, B, C, and D. Okay, here's part A. Now that you have your triangles built, we'll go into using these formulas. So sine of alpha plus beta is defined as sine of alpha times sine of beta. Keep the sign the same. Oops, wrote that wrong. Sine of alpha times cosine of beta. So it's sine of alpha times cosine of beta. This is the formula with the hybrid products. And then you keep the sign the same, and then you do another product like this, partly sine, partly cosine. Only the second time you write the product, you switch the angle. So if alpha was with sine, it's now with cosine, and the beta will be with sine. Okay, that's your formula for sine of alpha plus beta. Okay, then you're going to look at the alpha triangle, and from that alpha triangle, we need a sine value. Remember, sine is y over r, just so you don't pick the wrong values from the triangle. And from that same triangle, we also need cosine, which is x over r. So looking at this alpha triangle, central angle alpha, and grabbing the y and the r value, that would be 9 over 41. And then for the same triangle, doing the cosine values would be x over r. So negative 40. No, this is not negative 40. This is positive. Correct that before we go on. You're in a quadrant where this value is, everything's positive. X's are positive, Y's are positive. So I don't know why I had a negative there. So this would be the value that I'm doing right now. Cosine of alpha would be positive 40 over the r value, which is 41. Okay, now I'm going to do my beta values. I need a cosine and a sine value. Just get yourself focused here by reminding yourself that this is x over r and this is y over r. So off this beta picture, this was my beta picture. I built it based on these parameters. So cosine is x over r. This is your x value, the horizontal leg, and your r is 53. So 2 square roots of 53 over 53. And then this value is y over r, which is negative 7 square roots of 53 over the r value, which is 53. Okay, now let's start multiplying these fractions together. We're going to multiply top times top and bottom times bottom for each of these products. So this would be 9 times 2. You multiply this integer times this integer, and that square root of 53 hangs right off the back. back. So this is 18 square roots of 53 over a denominator of 41 times 53, but this also has the same denominator, so I'll just pull them into one fraction. This is a positive times a negative down here is going to be negative times positive 40. So this will be negative 280. That's 7 times 40. Negative 280 with the square root of 53 hanging off the back. Okay, and then this denominator, 41 times 53 is 2173. Okay, these are like terms because they are both square root of 53 terms, so you combine them by combining these coefficients. 18 minus 280. Put that in your calculator and you get negative 262. Okay, you can try and reduce this in your calculator just as a reminder how to do that. If it does reduce, when you hit math enter, you'll get a smaller version of this fraction. You wouldn't put the radical in there. So if you were going to try it out, you would just go 262. No need to put the negative in there because you can just copy that yourself. Divided by 2173. And instead of hitting enter, hit math, enter, enter. And it comes back the same way, so that means it's already in its most reduced form. Okay, so going to part B. Okay, in part B, you have cosine of alpha plus beta. Formula for that is cosine of alpha times cosine of beta. So it goes cosine, cosine, then you switch the sign, and then it finishes with sine times sine. Okay, so cosine of alpha, now you can just grab these values right from what we did in part A. Cosine of alpha is right here, 40 over 41. Cosine of beta was that 2 square roots of 53, but then you have to hope that you made no mistakes there. Then there's a minus sign, and it's sine of alpha, sine of beta. So sine of alpha was not, or you can just look at the triangle each time you go to do a value. You look at each of the triangles. And then sine of beta was negative 7 square roots of 53 over 53. Okay, now you're going to multiply just like we did in part A. We're going to multiply top times top, bottom times bottom for this product as well as this product. So this will be 2 times 40, that's 80 square roots of 53. They're both going to have the same denominator. And then here it's a negative 9 times a negative 7, so that's positive 63 square roots of 53. And then 41 times 53, we already know from part A that that's 2173. You can combine these two terms that are in the numerator because they are both square root of 53 terms. So 80 plus 63, just add the coefficients, this, and that turns out to be 143 square roots of 53. And the bottom is 2173. Again, you can check in your calculator as to whether this reduces by just putting 143 divided by 2173 and hit math, enter, enter. But that doesn't reduce. Okay, that's part B. C. In part C, we're going to be looking for sine of alpha minus beta. Okay, so just like what we did in part A, you have these products in this formula, that are part sine, part cosine. So it's sine of alpha times cosine of beta. Skip the letter there. So times cosine of beta. And you keep the same sign in the expansion. So if there's a minus sign here, there's a minus sign here, then another sine cosine product. Only switch the angles. Alpha was with sine, now it's with cosine, and beta goes over with sine now. Okay, so look at the triangles above if you'd like to get these values, or copy the values from part A. Okay, sine of alpha in part A was 9/41. Cosine of beta was 2 square roots of 53. I mean, this is just a duplicate of part A, only except it has a minus sign in the middle, and this one had a plus sign in the middle. Okay, that sine of beta value was -7 square roots of 53 over 53. And the cosine of alpha value was 40/41. Okay, then multiplying these out, just like in part A, you got 18 square roots of 53 for this first product, and we got 280 square roots of 53 for the second product, this 7 times 40, only the sign's different. This is negative followed by another negative, so this is like positive 7 square roots of 53 times 40. So this is going to be positive 280 square roots of 53 as opposed to negative 280 square roots of 53. All the rest of the numbers are the same. Okay, so then because you are now in a sum situation rather than a difference, so the value you're going to get here is different. So this will be 18 plus 280 is 298 square roots of 53 over 2173. And again, if you put this, the coefficients, not the radical, because that's a decimal, 298 divided by 2173, that does not reduce, so you leave it like that. And that is the answer to part C. Then in part D, now you're getting into tan of alpha minus beta. Formula for that is tan of alpha minus tan of beta over 1 minus the product of those two values in the numerator, tan of alpha, tan of beta. Okay, you might want to come off to the side and figure out what the tan, unless they're just like very non-complicated values, and I don't think they are for the alpha triangle. So tan of alpha, just remember tan is y over x. So if you were to do tan of alpha in this alpha triangle, y over x would be 9/40. Then you're going to subtract tan of beta. So again, y over x, now you're looking at the beta triangle. So y over x would be negative, I'll just put it down here and then I'll slide the paper up so you can see it. It would be this y value over this x value. Okay, so let me slide this up. This was the y value off that picture. This is the x value off that picture. Notice that these cancel. So that ends up just being -7/2 for that value. So this is the tan value for alpha. This is the minus sign, that's part of the formula. And then this is the tan of B value. Okay, you can get your calculator to help. I'm just going to continue with the numerator. Just put in your calculator, 9/40 plus 7/2, and hit math, enter, enter, so that it'll make a common denominator for you and simplify it. That double negative is a positive, so that's what you see me entering it as. Oops, math, enter, enter. You can do it afterwards if you want. So this is the fraction that you end up getting at the top. Okay, now let's work on the bottom. The bottom is 1 minus tan of alpha. The tan of alpha was that 9/40. And the tan of beta, after we got rid of canceled the radicals, because this was your tan of beta right here, y/x, it just ended up being -7/2. Okay, let's make sure these signs are right now. We had a minus in the put. This should be a plus right here, because in the bottom you should always have the opposite sign as you do in the top. So just distributing this tan across these parentheses gives you tan of alpha minus tan of beta. In the denominator, switch the sign, so that should have been 1 plus. Here's your tan of alpha value, here's your tan of beta value. Keep going with that. So this is 1 positive times negative is negative, so this is 63 when you multiply top times top. 40 times 2 is 80. If you want to put these together, this would be 80/80. That's the same thing as 1 minus 63/80. So let's see. 80 minus 63 is 17/80. Okay, and that's what's going on in the bottom of that fraction. Okay, once again, it was switch that sign because these two should have opposite signs. This was the tan of alpha value, 9/40. Tan of beta value was -7/2. This times this was -63/80. I called this 180/80 so I could pull these together. 80 minus 63, 17/80. That is the bottom fraction. Then you're left with a complex fraction, so to simplify it, float that divisor up to the top and flip it over. So this is no longer here, it's at the top, and you could reduce here if you want, or you could multiply it and then get the calculator to reduce it. If you want to get your calculator to reduce, it's just 149 times 80. Which is 11920, and then the bottom would be 40 times 17. 40 times 17, which is 680, and then you can get your calculator to reduce it by just doing 11920 divided by 680 and hit math, enter, enter. And you get 298/17 as the most reduced version of that particular answer. 298/17. Okay, moving on to example 13. Okay, so on example 13, this up a little bit. Okay. All right, so same thing here. You're being, trained in this problem on how to construct a triangle, get the values on there, find the missing value, and then use the formulas that you learned in this section. So here this says, make your alpha angle between -pi and -3/2 pi. Okay, so here's a little picture of that. Okay, you're spinning negatively, so this is -1/2 pi. This is -2/2 pi, also known as just -1 pi. This is -3/2 pi. Every quadrant is worth 1/2. And you're rotating this way. Okay, you keep rotating, rotating, and they want you to stop your rotating between negative pi and negative 3/2 pi. So you're up in here. This is your triangle. And in that triangle, they're giving you a y value and an r value. So your y value is 3. Your r value is 5. The r value is the hypotenuse. And you're looking for x, which is going to be negative, because x's are negative over here. So we can Pythag our way to that value just by using hypotenuse squared is equal to leg squared. This 3 represents one of the legs, and the x is the other leg. Okay, I've squared everything. I've squared the 5, I've squared the 3, I've squared the x. Bring the 9 over here, it becomes a negative 9. You then have 16 is equal to x squared. And to turn that x squared into an x, you're just going to take the square root of this side as well as this side. So x is 4, but because of the quadrant this triangle is in, that x value will be negative 4. Okay, so that represents your alpha triangle. Then you're also going to construct a triangle based on this beta information. Okay, in the beta triangle, they ask you to go between pi and pi over 2. This time they're talking positive angles. This is pi over 2 if you spin this way from 0, whereas here you were dropping down so you could rotate in a negative fashion. So this was, we want to be between pi over 2 and 1 pi. Okay, so if you're right in here between these two, you are once again in quadrant 2. Okay, put the numbers on the triangle that you've been provided with. One of them is negative, either this or this. We can talk about that, but the tangent's defined as y over x. Y value is the vertical leg. Y coordinates are not negative in this quadrant, but x's are. So that negative belongs to this. So x is negative square root of 3. And this time you're finding the r value. That's the only value that's missing, but will be required here. So that r value, we'll use Pythagorean theorem, and we'll go hypotenuse squared is equal to 1 leg squared. You got your vertical leg, you got your horizontal leg. There's this leg squared, and then here's the other leg squared. So this will be 1 plus 3. Square root of 3 squared is has to be positive. Anything squared is positive. And when you square a square root, out comes the radicand. So you have 4 for your r squared value, but by the time you take the square root of both sides, you have 2. Your r value, your hypotenuse, is always positive. Just the legs have the ability to be negative because they represent x and y, and based on the quadrant you're in, x's and y's can be sometimes negative. Okay, now after we've built both of these triangles, we finally get the chance to come down here and do parts A through D. So this will be sine of alpha plus beta. And that formula is a product of sine times cosine in the front and a product of sine times cosine in the back. Okay, we're going to pluck these values right off of the triangle. So sine of alpha, that's from this first picture. Second triangle was my beta triangle. So sine of alpha is y over r. Remind yourself how you're going to construct these values. So the y value is 3, and the x value was negative 4. I'll just pop that negative right out there. Then x over r, I might as well continue with the alpha triangle just so we're not going back and forth. We also need an alpha value down here for cosine. So cosine, and I think I messed up already. Sine of alpha Let me fix that. This is supposed to be y over r. I did not use the r value, excuse me. So that's y over r right there. So we have 3/5 for that. And then the other alpha value that I was going to try and get was the cosine of the alpha value, and that would be x over r, because that's what cosine is. So x over r would be -4 over a value of 5. Okay, then continuing with that, let's get the values for the beta triangle. And in the beta triangle, we need cosine. We also need sine. So cosine for this beta triangle is -√3 over the r value, which is 2. And the sine of beta is y over r, so 1 over 2. So this is going to be 3 times square root of 3. Which is like this. 3 times square root of 3 with a negative from one of the terms is going to be like that. And then plus followed by a negative is just going to be a negative, -4. And then both of these have a denominator of 10. Okay, so that's one of your answers right there. 3 square roots of 3, negative at the front term, -4 in the back, denominator of 10. Okay, part B. In part B, I'm going to be doing cosine of alpha plus beta. That formula goes like this. Cosine, cosine, switch that sign, and then go sine, sine. Okay, so we check this real quick. Square root of 3 over 2, that was negative square root of 3 over 2. That was positive. Just checking my numbers here. Over r, and cosine of alpha was, because I want to reuse them, so I have to be careful here. Okay, so we need cosine of alpha and sine of alpha. We need cosine of beta and sine of beta. Okay, my alpha values, let's see. Let me just get these values from what I did in part A. So cosine of alpha was -4/5. I can just look right there. My cosine of beta value was -3 square roots of 2. And that was in the beta picture when we were doing cosine. That was x over r. And then sine of alpha, my sine of alpha value was 3/5. I'm just using the values I got from part A. I did it already. And the sine of beta is 1/2. Okay, so then when you go to multiply these, this is negative times negative. So that's going to be 4 square roots of 3. Over 10, and then this will be negative, so this is negative times negative is positive, 4 square roots of 3 over 10, and then this back product will be 3 over 10. And that's the value for part B. Okay, then for part C, we're going to be doing sine of alpha minus beta. And that expands into sine of alpha cosine of beta plus sine of beta cosine of alpha. So we have sine times cosine products in the front and the back for this formula, and the sine should be the same. Okay, so sine times cosine, but notice that I've switched the angles. I had alpha with sine, now I have alpha with cosine. And for the sine formulas, whatever the sign is in the parenthesis, it's the same thing in the expansion. Okay, now I can take these values and start plugging them in. Okay, so sine of alpha from part A, I can just use what I did in part A, was 3/5. Cosine of beta was negative square root of 3 over 2. And then for sine of beta was 1/2. Just use that from part A. And then cosine of alpha was negative 4/5. Okay, if I multiply these out, this is 3 square roots of 3, negative, over 10. And this is negative times another negative down the road. That would be positive 4/10. Okay, so that's the answer for part C. And then part D, now I'm doing tan of, and you're asked to do tan of alpha minus beta. So this would be tan of alpha minus tan of beta. And then it would be 1 plus, switch that sign, and do tan of alpha, tan of beta. Okay, so tan of alpha, that would be y over x. Let's just remind ourselves that that's y over x regardless of which one we're looking at. So tan of alpha, here's that alpha triangle, so y over x would be 3/4, and it would be negative. Okay, then it's going to be minus. Then we're going to do the tan of beta. Here's your beta picture once again. And y over x would be 1 over square root of 3. You might want to simplify that first instead of bringing it over to the main triangle like that. Tan of beta would be 1 over square root of 3. It is negative, and you'd probably want to bring it over in its rationalized form. So that would require multiplying the bottom by square root of 3 and the top by square root of 3. So this would make it square root of 3 over regular 3 with a minus. So this was the tan of alpha value. This minus sign was from the formula, and then the value we're plugging in for tan of beta is another negative square root of 3 over 3. If I'm going to keep working on the top, these both need to be the same denominator. So I'm going to multiply by 4, top and bottom. I'm going to multiply this one by 3, top and bottom. So that would be negative 9. Both of these now have a denominator of 12. So that would be negative 9, 3 times negative 3. This would be a positive. So this would be positive 4 square roots of 3 over 12. Okay, that's just the top. And then on the bottom, it's 1 plus tan of alpha times tan of beta. And that tan of alpha was this value right here, negative 3/4. While the tan of the beta value was, I had done it right there in the corner, square root of 3 over 3, negative. Square root of 3 over 3, negative. So this is 1 negative times negative is positive. 3 square roots of 3. Top times top is 3 square roots of 3, while the bottom is 12. You can pull these together into one fraction before bringing it over here by just calling this one 12 over 12. That's the same thing as 1 and adding it to this. So when you put this 1 together with this, but in its form 12 over 12, it's 12 plus 3 square roots of 3 over 12. And that would be the denominator here. Okay, so you have a complex fraction here. And I'm going to leave the top fraction alone. Negative 9 plus 4 square roots of 3 over 12. I'm going to take this and float it right up to the top, right alongside of that fraction, and multiply by the reciprocal. 12 plus 3 square roots of 3. The 12s would cancel, leaving you with negative 9 plus 4 square roots of 3 on the top. And it would leave you with 12 plus 3 square roots of 3 on the bottom. I don't believe they'll make you rationalize that, only because you've gone through so many steps at this point, and they tend to do that sometimes, that if you've gone through a gazillion steps already, they will allow you to leave it like this. If they do ask you to rationalize that, you would multiply the bottom by 12 minus 3 square roots of 3. You would multiply the bottom by the conjugate and the top by the conjugate, but I believe they'll let you keep it there. Okay. And I think, you know, what I'm going to do, let me give you the answer in rationalized form as well, just in case they ask you to do that. So for part D, if they ask you to go further beyond this, then you'd have to take this, multiply it by the conjugate, which is 12 minus 3 square roots of 3, and you'd have to multiply this by 12 minus 3 square roots of 3. Okay, being that the bottoms are conjugates, you can get them FOILed out by square minus square. And when you do the square minus square, you could either be looking here or here. Doesn't matter, because you're going to square the front, square the back, and you're going to get positives both times and then throw a minus in between them. So squaring the front term, you'd get 144. Squaring the back term, you'd have to square this, you'd get a 9. You'd have to square this, get a 3, then multiply those two. So the square of the front is 144, square of the back is 27. Throw a minus in between those squares. So 144 minus 27 is 117. And then if you're going to multiply these out, there's no shortcut here. Those are not conjugates, and they're not squaring the same binomial twice, so you have to just do full-blown factoring. So when you multiply these out, it would be negative 9 times 12, which is negative 108. Then it would be negative 9 times negative 3. Which would be negative 9 times negative 3 would be positive 27. Negative times negative, positive 27, square roots of 3. Then you'd multiply this times this, which would be 4 times 12, 48 square roots of 3. And then you'd multiply this times this, so that would be 4 times negative 3, negative 12, and square root of 3 times square root of 3 would be 3, which would give you a negative 36 in the back. Okay, so putting these items together, you would have negative 108 and negative 36 combined. That would be negative 144. And when you combine the 27 and the 48, you end up with, let me just write it down here, I'm running out of room there. It's 144 when you add this and this negative 36 that we got back here. And then when you add these square root of 3 terms, you have 27 plus 48, and that's 75. 75 square roots of 3. And then on the bottom, 144 minus 27, we had already done that, is 117. That's your answer there. Okay, so just in case they ask you to rationalize that answer that I had gotten right here, negative 9 plus 4 square roots of 3 over this, I multiplied by the conjugate here and here. And I came out with all the work that I've shown you here for a rationalized answer. In other words, no radical on the bottom now. Okay, last one is number 14. And in problem number 14, you're being asked to establish the identity for tan of 2 pi plus theta. So tan of 2 pi plus theta, formula is tan of 2 pi plus tan of theta. Formula is a fraction, and then it's 1, switch the sign, and then go use the values that are at the top. Tan of 2 pi times tan of theta. Okay, at 2 pi, which is really the 0 location, you want to know what the coordinates are right here. Coordinates right here are 1, 0. Okay, this is x, this is y, and that's what's required to get a tan value. So the tan at 2 pi, which I'll be plugging in here, is y over x. 0 over 1, or just 0. Everywhere you see tan of 2 pi, you're going to put in a 0. Okay, so this would end up being 0 plus tan of theta, and then it would be 1 minus 0 for tan of 2 pi times tan of theta. Then 0 plus tan of theta, tan of theta. And then 1 minus 0 would just be 1. And that's how they end up with just tan of theta. So let's find the answer that goes through all those steps. Okay, so first thing I did is expand tan into the parentheses here. Tan of 2 pi plus tan of theta. That was my numerator. Then in the bottom left-hand corner, there's a 1. Switch the sign, do the product. Tan of 2 pi times tan of theta. Then I evaluated tan at 2 pi. Here's a little picture of me being at the 2 pi location, which is really just the 0 location. Coordinates are 1 and 0. 1 for x, 0 for y. If you move 1 out and you're 0 units up in the air. So when you go to evaluate the tan value at this location, and you use the definition y over x for tan, you get 0 over 1, which is 0. So everywhere that I saw tan of 2 pi in this expansion, I put a 0. So I put a 0 in for here and for here. That left me with 0 plus tan of theta at the top. Down at the bottom, 1 minus, again putting in a 0 for tan of 2 pi, times the tan of theta it was multiplied by. When I simplified here, 0 plus tan of theta is just tan of theta, and 1 minus anything that's being multiplied by 0 is just 0, so this is 1 minus 0. Or just 1, and I ended up with tan of theta. So what looks like that? Let's see, my first step was this. Let's see if this fraction is correct. 1 minus tan of 2 pi times tan of theta. Perfect so far. Then I plugged in a 0 for this tan of 2 pi, so did they. I had plus tan of theta, they did too. Then at the bottom they had 1 minus 0 times this looks perfect. Okay, it's choice A. This is all the proper steps. Okay, that completes second video for section 7.5, numbers 11 through 14.